sines and cosines, you've got that generic form of y equals a sine b x minus h plus k. Sometimes what they do is they will put in a like -2 sine pi x minus pi over 2 plus 4. They might do that. What happens here is that they embed the b value inside the parentheses. This is a very common tactic. They do that a lot just to mess with you. So what happens here, actually change this to just maybe 2 pi, make that easier. What happens is that they're trying to force you to take that first coefficient out by adding one step to finding what your h value is. So is this kind of what I did? Oh.
Grab me if
Yeah.
like, if you want like.
Because I'm going to show an example of this here later.
Because if you had like y equals like 1 plus like 2 sine x, and then like the next thing you did was like 2.
Oh, okay. What they do is a lot of times this is still the k value,
Yeah.
but sometimes they put it up front. That's all.
Yeah, but you put the x minus f.
Because I just created a problem. This one doesn't have a horizontal shift, so I just made a quick example by adding in a horizontal shift by doing this and just rewriting it into a standard form. That's all it was. That's all it was. I was taking an easy example and adding the step to it. Does that make sense, Trent?
Yeah.
Yeah, the book a lot of times.
It's just
Nerds. Yeah, a lot of times the textbooks and stuff, they put that k value up front for no apparent reason except for that sometimes they do that. But let's see how you did. Do you have any particulars on questions and things of the shift or the non-shifted things where you guys had some equations at the end? Let's see, it was in 10-4. No, that's not it. Yes, ma'am.
Kind of like preposition, like with the parentheses.
Yeah.
There's one that it was cosine, and then in parentheses 2x plus pi over 2.
Yes,
That should be changed to like cosine, like 2, and then x plus pi over 4.
That's exactly right, because you take 2 out, because that's exactly what you have to do.
Okay.
That's kind of like the worst case scenario for most of these things. You see that a lot. It's not arithmetic. You see that a lot, especially, I try to do that with you guys more, because that's what they do in pre-calc. So there's my preemptive pre-calcing you guys. That's a word. So you guys did, it was this chunk, right? 3841, 3846, I think? Was that right? 3843?
38 to 130.
Okay. Is there any one of those 6 you guys like to double check, make sure we're okay with?
I did this.
Are we all right? It's kind of weird, not.
It took forever.
They take time, yes. They take time. Let me walk through at least one, just to make.
You do 43.
Sure. Let's look at 43 then. 43 is a cosine. So we have y equals 4 cosine x minus pi over 2 plus 6. And I'm just rewriting it by putting my k value on the right. It's just more traditional that way. So as you start putting it together, always go by labeling A, B, H, and K. Our A value is 4. Our B value is 1. Our H is pi over 2. And our K value is 6. Okay. That means that our period is 2 pi, because it's just 2 pi over 1. We're going to have a horizontal shift of going to the right, pi over 2. So one of the things I hope you might have recognized as you were drawing these things out, you know how most of you guys start your papers, you got your, oh sorry, that's a red line. The red line going down here, and you've got your blue lines going across. A lot of you guys will start your graphs by writing out the equation, then you'll say, oh, it's going to be this. Well, a lot of times what I want you to try and do is don't tuck your graphs all the way to the left like you normally would, especially when you start talking about shifts. Sometimes your shift brings you to the left, and this gets really, really scrunchy. Move this part over to the middle a little bit, so you have a little bit more room to work. But it's a piece of paper. How do you guys not understand me? Jeez, you've been around me all year.
2 years now.
You should understand everything. Well, at least understand what I'm trying to say.
Yeah.
Understand the concept. So what I'm going to do is, knowing that I'm going to have to move things to the right a little bit, I'm not going to put my parent function period all the way at the end. I'm going to put it just over a little bit to the left. That way I have more room to work later on. Does that make sense?
Yeah.
All right, so we have 2 pi, pi over 2, and 3 pi over 2. I should have lowered. Also, another trick, did you guys catch up on this also? Well, not catch up on it, but like catch onto this, where if you have a shift that's moving upward, to put your graph a little bit lower and extend this line up a little bit higher, just to get in the mindset knowing that you're going to have to raise it or you have to lower it. You kind of fudge around with the parent function a little bit. Did you guys try to do that a little bit?
Maybe not.
Well, that's good then. Cosine. Does cosine start at A or does cosine start at 0? A. It starts at A and it goes through the cycle. Parent function, solid or dotted? I said that, right? And now we have to shift everything. Knowing that some of you guys, I know yesterday in the video I showed how to list your ordered pairs and then just adding or subtracting. Usually that's a very easy thing to do because then you're not going to really mess up, excuse me, not going to mess up your fractions as much. But also sometimes, especially when your shift happens to be the same breakpoint values as your parent function, it's really, really easy because all you have to do here is basically move one more part over. Instead of being 2 pi, I add 2 pi to that, which is 4 over 2. I get 5 pi over 2 is my last spot. And then maybe you just realize that just everything moves over and up. So we're at oops. Over, up, over, up. Oops, sorry, 6. Over, up 6 goes to 2. Over, up to 6. Over, up to 10. And you got that, where this was at pi over 2, 10, pi, and 6, 3 pi over 2, 2, and so on. Does that help? Did you guys get that one okay?
Yeah.
See, it's not that bad. All right. Well, shall we do tangents then today?
It was
Psych.
really frustrating because on one of the problems I did like 2 pi and then I did like pi and then pi over 2 and then I was like, you put it on the last one, but then I put 3 pi over 4. So then I was doing it and I was like, getting so angry. I was like, that doesn't make sense. Like, all the points are right next to each other.
You make one stupid bonehead spot on a first placement, you just kind of like, poop. All right. Make sure your names are on that and send that up, and we'll talk about tangents.
Mine's connected to the
fine, that's fine. Oh yeah, did you guys have any questions about the one before about writing the equations? Was that okay with A value is positive and B value is positive? That was pretty easy, right?
Yeah.
Yeah.
I forgot to write down the page numbers, so.
Well, I'm sure you kind of figured it out. You just had to look for it. The other thing is that the reason why they gave you those instructions in 14.1, where it said that they're telling you that he wants you to write the equation of a sine equation with an A and B value, is because as we get into this stuff more, you can actually write a sine equation or a cosine equation, depending upon what information you're given. All right? If I give you a graph, it could be either or, because it's dependent upon how you want to write it. Because remember, sines and cosines are the same graphs. Oh, I'm sorry. My bad. I didn't know which one. I thought they were the two sides. My bad. Thank you, sir. Yeah, I'll take a both. Yeah, I'll take a both. Thank you, ma'am.
Wait, you want both of them?
Yes, please.
This one?
Sure. Other graphs of sines and cosines?
If I just write Maddie, do you know who it is, or do I need to put my last name?
Well, I think it'd be okay because the other one wasn't here for 2 days. So.
Well, Anna spelled it differently.
Oh, you do? I don't get it. If I do, I don't pay attention. 'Cause that's too much work. Thank you, ma'am. Sir? Ma'am? That's unacceptable. You this dirty, ripped paper. Jeez. Are you new? Alright.
I don't wanna buy it and then get it. It's easy to have. You know what I mean? Like, you buy it and then open it.
So let's look at tangents. Tangents are the oddball of the groups when it comes down to. Tangents are the oddballs in the group when it comes down to graphing. They still have their own rules, but what happens with tangents is that, as you guys remember, tangent has asymptotes because at 90 degrees and at 270, tangent is, or better yet, at pi over 2 and 3 pi over 2, tangent is an undefined value. If you're on the unit circle, remembering that tangent of theta is y over x, well, that means that this is 0, -1, and this is 0, +1. That's why tangent is not a periodic function, because it's not a, I should restate that, it's not a continuous function. I forgot what it was called. So what happens with tangent is that tangent has the tangent has this. If I'm looking at a generic form of tangent by just following through on the unit circle, if I look at my quadrantals, remember that tangent is y over x. If I list out my quadrantals like we have before, I get 1, 0, 0, 1, -1, 0, and 0, -1. You okay with that? Now, excuse me, as I go through this, if I'm looking at a graph, at 0, tangent is 0 divided by 1. What's 0 divided by 1? 0.
So you can 0 divided by 1 undefined?
No, 1 divided by 0 is.
Oh.
That's a 0, not a 1. I know my handwriting's bad.
The 8 that looked like an existence, that looked like an
Now, the other, at pi over 2, tangent is undefined, because you get 0 over 1. Thank you, screwed me up. You can say 1 over 0 at pi over 2. So at pi over 2, tangent is undefined. So you get an asymptote. Now, if I continue on to the right, I would get, my next value would be at pi, and then I'd be back at 0, and then my next one would be at 3 pi over 2. Well, when I graph tangent, I'm graphing tangent between pi over 2 and negative pi over 2. That's how I can encompass between one, I don't know, if you want to call it oscillation of tangent. Because at negative pi over 2, tangent is once again undefined. Right? Now we also wind up with values that tangent equals 1. Where's tangent equal 1? What angle gives tangent a value of 1? At 45, which is your pi over 4. My tangent value here is root 2 over 2 divided by root 2 over 2, which is 1. So at pi over 4, tangent is 1, which means that at negative pi over 4, tangent is negative 1. Will tangent ever equal negative pi over 2? Can it get infinitely closer and closer and closer to it? Yes. As close as it wants, but it won't get there. Same deal. So what happens is you get tangent that looks like this. Tangent is increasing from right to left, left to right, sorry. It's increasing from left to right, and it has basically 3 breakpoints. The breakpoints are always going to be at 0, pi over 4, and negative pi over 4. Your asymptotes will always be placed at pi over 2, which means
How is it different?
I could shift it and add a's and b's to it. But what happens though is, how far apart is pi over 2 and negative pi over 2? Pi. The distance between those two values will always stay the same. It'll always be pi apart. Whether or not you have a shift or anything else into it, the period for tangent is always pi. All right? Now, excuse me. What I want you guys to think of then is we get these generic ideas for tangent graphs. We're going to start with the idea that, can I go back to the other note part here real fast? You all right? Yep. What happens then is that you get your tangent graphs. I don't want to do this one. That was bad. Get it?
So sine divided by cosine is tangent.
Because tangent sine is y over x, sine over cosine. Sine gerene, cosine gerene is. Shut up. It would be something Gunderson would say. So generic form, parent function. Parent function of tangent, a tangent b of x, or b times x, excuse me. Your, excuse me, your a value is going to be how high up you place that your pi over 4s. If your a value is 1, it's at 1. If the a value is at 2, it's going to be at 2. A value is 7, it'll be at 7, negative 7. That's where the a values come into play. Your b value helps you denote how far apart, well, the distance between for the period for tangent is always going to be pi, but if you have a b value, it's just broken into different chunks. So what we get is your A value, I don't want to, it's not technically an amplitude, so we're going to say it's amplitude-ish. Because remember, sines and cosines, your amplitude was how high up it went or how low it, or the highest value, lowest value. I want you to think of this as where it changes directions, where our breakpoints go. Once we do a couple of examples, you'll see right away. And also, just like your A values for sines and cosines told you whether or not they went up first for sine or down first for sine, if it was positive or negative. If my A value is negative, instead of being increasing from left to right, I am decreasing from left to right. So the A value will change direction. So if A is positive, it does this. If A is negative, it does that. That's all that means. All right, that's all that means. And that A value, when I'm talking about those breakpoints, that's where those two other points decides where the origin part would go. All right. Your B value,
What's BOS is
positive.
positive and irregular?
I know your glasses are not near you, so I will help you out for a second. Because
Oh wait,
I am nothing
positive
but
and negative.
I am nothing but a caring person.
I thought it said regular.
That says negative. Can you see it now? And then this one says, can you see that okay?
Why are there two S's?
I don't know.
There's only one.
Because I didn't want you to think of it as a piece of
I thought it
Nikes.
said possessive and regular.
Yes, it's all about me. It's mine. It's my ideas. See what I did there? Possessive. That's what it works for, right? I don't know. I took like one English class in college, and I think I barely got a B in it.
I thought it said REG.
And then the period for a tangent is going to be pi over b. Again, they throw the absolute values around the b value. I honestly don't think I've ever seen a negative b value. We do worry about that in pre-calc when we talk about
I
negative
thought the
angles.
period was always pi.
But just like before, you could have a scalar. That b value is your scalar. Okay. All right. So let's do a parent function. Parent function. Y equals 3/2 tangent of 4x. Y equals 3/2 tangent of 4x. Examples. What's my A value?
3/2.
3/2. Is it positive or negative? It's positive, so that helps. What's my B value? 4. Okay. So our A value is 3/2. My B value is 4, which means my period is going to be pi over 4. That means that,
Does that mean it's negative pi over 4?
no, it means that the distance between the two is pi over 4.
She said it was always pi.
The, for the generic equation of tangent, yes, the generic equation of tangent, the period between, the distance between negative pi over 2 and pi over 2 is pi. So that's the period for the generic. So now they're telling you that your period, because there's this scalar thrown in here, the period now is pi over 4. Well, if pi over 4 is the period, that means that when I place my asymptotes, this distance from here to here is pi over 4. Which means half is going to be on one side, the other half is on the other. So what's half of pi over 4? Pi over 8. So that means my asymptotes get placed at pi over 8 and negative pi over 8. Since there's no h's and k's yet, I don't need to worry about the next statement. Tangent will always go through 0 for the parent function. always. Okay? Because what's 4 times 0? 0. Tangent of 0 is 0. And 3/2 times 0 is 0. Okay? So I know that no matter what, my tangent's going to, for the parent function, will always go through 0. The other two parts I put in are going to be the halfway spots between 0 and the asymptote. So what's half of a fourth? Be an eighth. So it's pi over 8 for, oh, I'm sorry, thank you. So half of the eighth is a 16. So it's pi over 16 and negative pi over 16. My a values are the other spots that I put on the y-axis. My a values are 3/2, and the other one would be at negative 3/2. So I'll just label it 3/2, negative 3/2. Was the a value positive or negative? So that means it's going to be going up and to the right, so I put a dot here, here, and here. And there's my curve. Tangent gives you 3 ordered pairs. You have 0, 0. I'm sorry, going from left to right. You have negative pi over 16, comma, negative 3/2. 0, 0. Pi over 16, 3/2. And your two asymptotes at x equals negative pi over 8 and x equals pi over 8. Those are your two asymptotes set. Those are your critical values for graphing a tangent. Yes, sir.
I don't think how you find the 2 points,
Which 2 points?
like negative pi over 16 and negative 3.
Okay. What happens here on a tangent graph, you get half of all the action is on one side, between 0 and pi over 8. What's half of an eighth? A 16. The other half of the action is between 0 and negative pi over 8. What's half of negative pi over 8? Negative 16. That's it. These points here are always going to be halfway between here and here. Always.
Yeah, no, but like how do you go, how do you find like the actual point? The negative pi over 16 and then the negative 3.
Multiply that by half. That's it. Just multiply by half. What I want you to think of is at tangent. Tangent is, it's undefined. It's 0. It's undefined. At 45 degrees, tangent is 1. At negative 45 degrees, tangent is negative 1. What I'm doing here is I'm figuring out what multiple gets me to this value of 1. It's 45 degrees is halfway between undefined and 0. 90 and 0. Negative 45 degrees is halfway between 0 and negative 90. That's all I'm doing. That's where that breakpoint comes in. It's just halfway. Yeah, and that point will always be a. Because it's just the scalar multiplier to get a 1. Just like when you had sines and cosines. When you had sines and cosines, when you started out your breakpoints, you ended out here, you took half of it, you took half of it, and you added the other half here. And you went up, well, whatever, you did something like that. Listen, if you squint really well, it might look right.
Yeah, close
How did I get all these points? Well, this is where I ended. I took half of it. I took half of it. I took the and added the half in. It broke it into quadrantals. Well, a tangent graph, all the action starts in the middle, and you got half on one side, the other half on the other. That's all it is. You're still using 4 spots. I just moved the center from the end to the middle. That's all I did. Okay? That's all I did. Because otherwise I'd be graphing, if I graph tangent like this, where I did just the first half of it, I'd be moving my way up like this, and then I'd have my asymptote. And then my other part of the graph then would just look like, let's see where it would be. It would look something like this. And that just looks weird. That's why they just oscillate tangent between the two sets. That's why they shifted over to the left. That's all they're doing. Okay? They're just moving their scale. You'll get it. Let me do another one. 1/4 tangent pi x. And then we'll add in an h and k here. We might. I don't know. Depends on how much time we have. So I have 1/4 tangent pi of x. That gives me an a value of a fourth, a b value of pi, and a period of pi over pi, which is
1.
1. So that means that the distance between my asymptotes is going to be 1. One going positive and one going negative. So if I place them in, knowing that this distance has to equal 1, half of it is on one side, the other half is on the other. What's half of 1? 1/2. So I have an asymptote at x equals 1/2, and I have an asymptote at x equals negative 1/2. Tangent will always go through what value for a parent function? 0. Tangent will always go through 0, which then means that half of the graph is going to be on one side, the other half is going to be on the other, but I have to put in my other breakpoint. What happens between halfway between 0 and 1/2? 4. What's happening between 0 and a negative half? My a value is a fourth, so I just put it in here. Was the a value positive or negative? Positive, so it's increasing from left to right. There's my graph. I'm still using the four main spots, or I'm sorry, 5 for a full oscillation. But instead of starting at 0 and going to the right, I'm just cutting that and moving it over. Okay. Let's put an H and K in here real quick before we run out of time. Let's try one over to give time. Oh boy, this looks exactly the same. Y equals A. What do you think the H stands for? High? Wrong. What does the H stand for? The what? The horizontal shift, the X shift. The K stands for the vertical shift. It works. So what happens then is that you're just moving things left and right. You still plot everything like you would normally. You start by plotting one of these words. I'm planting grass seed. I'm overseeding my yard with all the bare spots. So I've got planting and plotting and doing all that. You start by graphing your parent function, not your parrot. You don't want to graph a parrot, that would look weird. You start by graphing your parent function, list the ordered pairs, and you saw yesterday it's a little tedious, but if you add in your fractions that way, it's a little bit cleaner. Then you just redraw your asymptotes and stuff. Okay. So, let's try it. Let's put a scalar in here too. Let's say it's, nah, we'll leave it out. We'll leave it as it is. We're running out of time anyway. Let's do this one. We'll add a K. I see what you did there. So y equals -2 tangent times parentheses x plus pi over 4, all plus 3. Now remember, they will put that plus 3 out front. That might say 3 minus 2 tangent of the junk. That just means 3 is the K value. That's actually more traditionally what you will see, especially when the A value is negative. That way they force you to remember that it's a negative thing. So list out your values, and you know that A is -2. Our B value is 1, which gives me a period of 5. What's my h value? Negative pi over 4, very good. It's negative pi over 4, and a k value of 3. I will suggest on tangent graphs, if you've got two different colors, use them, because you have so many asymptotes going on, that way you know what you're looking for, or a pen pencil, if you're, really crazy. Start by going for your parent function. My parent function has what? Period of pi. So I'm going to have asymptotes at pi over 2 and negative pi over 2. So those are my first two asymptotes. I know that one of my ordered pairs is going to be at 0, 0. My other ones will be at my breakpoints. Breakpoints are pretty quick here. Pi over 4, negative pi over 4. My a values are at 2 and negative 2. My a value is negative 2, so what direction is this moving? It's moving from top down. So I have it at here, here, and here. And then I just do my. So ordered pair would be at negative pi over 4, 2, 0, 0, pi over 4, and negative 2. To each of these, asymptotes included, I have to move everything to the left, to the right, hi, good morning everybody. I have to move everything to the left, pi over 4, and then I have to move everything up 3. So it's going to be, sometimes if you write it, it's going to be x minus pi over 4, comma y plus 3. Can I move vertical asymptotes up and down? No, so that doesn't matter. I just have to shift those to the left. The rest of them, if you notice, since your h value is one of the factors of your breakpoints, it's not that bad to move this one, is it? I always suggest starting by moving your asymptotes. Once you move your asymptotes, then you can find your halfway, and then you can find those secondary halfway points. So if I move my asymptotes, if I move pi over 2 to the left, where do I wind up at? Very good. So my positive asymptote becomes.
So you're supposed to move it like wherever the x tells you to, like the x, because it's x minus pi over 4. So
Yep. So I just move, what's 1/2 minus a fourth? It's a fourth. Which means on this side I have to move it over again, and I'm going to put a new asymptote in at negative 3 pi over 4. So those are my two new asymptotes. Breakpoints. I can go, if I started at 0, if I move 0 to the left, and then I have to move it up. So I'm at pi over 4 and 3. I'm sorry, negative pi over 4 and 3. The other one will be at negative pi over 2 and 5. And this one will be at 0 and 1. And yes, sometimes these tangent graphs get kind of messy with the asymptotes and the parent functions. But the idea is being able to list out your ordered pairs. If you list out your ordered pairs, that's so important to be able to do. I know I'm running out of time. I am sorry. We'll do more tangent stuff tomorrow, but let's try these. So it's 8:45. We'll do 44, 49. Those are tangent ones. I'll pop it on here. There's like one parent function. do parent functions and shifts, and then we'll talk about how we word everything here. Oh, why didn't that work? Oh, there it is. All right. So work through those. We'll do a little bit more of the graphing tomorrow as far as how do we interpret what the equation is from a graph, and we'll work a little bit more I'd say,
Is it 14.2?
yeah, this is still 14.2. Yes, sir.
So you want us to like write out the point?
Yeah, tangents are so much easier to write out the orders, variance, and sines and cosines because there's only 3 of them and asymptotes. You wind up with a little bit weirder fractions a lot of times with tangents than you do sines and cosines, if that makes any sense. Yes, ma'am. Oh, yeah.
Thank you.
Mm-hmm.